Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gents. Thank you very much for Professor Halida. Thank you all for your presence in this today's presentation. Before I begin, let me introduce myself. My name is Dayatno from Forestry Faculty Universitas Mawarman. And the title is already changed. Yeah. The title is Improve Quality of Wood Plastic Composite or double UPC through the addition of maleic anhydride. The first, I try to explain about the double UPC or wood plastic composite. WPC is one of composite products that offer protection for environment, the rigidity and look of wood, and toughness and processability of plastic. WPC has same benefit usage of waste material like straw, wood, and other trash, as well as safety and environmental protection, low water absorption, resistant to deformation or cracking. And then, next. In this study, we discuss more about the weakness of WPC. We know that wood and plastic are not bonded properly to each other because it comes from different character. Plastic with hydrophobic properties, it means doesn't like water. Meanwhile, wood with hydrophilic properties, it means likes water. So it will produce later low value of physical and mechanical properties of the WPC. Next. So what the solution to get the improving physical and mechanical properties of WPC? I think one of many solutions is addition of maleic anhydride as additive into WPC making or production. Next. The question is, what is maleic anhydride? Maleic anhydride, basically the form is granules, like sugar or rice. And then the chemical structure is shown in the picture, like that. And Ma as compatibilizer and coupling agent, added to mixture of wood and plastic, making into WPC board, and we hope Ma will be improve the bond between wood particles and plastic. Next. The next question is how Ma works in WPC board. Ma is chemical with two different functional and groups are coupling agent, like that, while some of the groups are utilized to interact with plastic. Others are employed to react with the hydroxyl group of wood particles, shown in the picture like that. Next. Yeah. The last question is how many percent Ma add on WPC? So we think the amount of Ma is percentage is of the weight of the WPC board. With the formula for calculating the material, we can determine the number of grams of Ma needed in the WPC board. Next. We tried, in this research, we have tried the addition of 4% and 8% Ma. Then we carry out measurement tests for physical and mechanical properties of the WPC board. Physical properties, namely density, moisture content, water absorption, and thickness swelling. And mechanical properties, namely modulus of elasticity and modulus of rupture, also internal bonding strength. Next. And we can see on the picture that physical properties of WPC generally, increasing Ma has improved the physical properties of WPC board. We have the analysis that the WPC density rises with the addition of the Ma ratio. There may have been a esterification reaction between Ma and the OH group of the wood particle, as well as a validation reaction between Ma and the plastic, which resulted in a strong bond between the plastic and wood particle, achieving WPC compatibility and resulting in a reduction in voids and an increase in WPC density. At the same time, gases with moisture content, water absorption, and thickness swelling decline. Next. This is about the mechanical properties. Generally, the result is the increase in Ma causes an increase in the mechanical properties of the WPC board. And the analysis is initial crack with result from void or cavities in the specimen because stress concentration happens when the WPC is exposed to a load or force. There's a possibility that as a result, the value of the WPC mechanical strength will decline. With the pressure of Ma in the WPC board, the problem can be turned back, improving the WPC board strength. The mechanical strength develops as Ma composition increases. Next. We already using statistical analysis with ANOVA, and Ma has a very significant effect on almost all physical and mechanical properties, except modulus of rupture. The explanation is the ability of Ma as a coupling agent, especially attaching to the surface of wood particles on one side and binding polypropylene and polyethylene plastic on the other, demonstrate that Ma is extremely successful in altering physical and mechanical properties in this situation. The last analysis, next. We try to compare with the Indonesian standard, SNI 8154 2015 standard. And the result is physical properties meet the standard, but not the case with the mechanical properties. Because they're related to the level of load that WPC board can support, the mechanical properties of WPC board are given priority for evaluation as a requirement for a structural application. Data on the table indicate that the WPC board not enough yet satisfied. So, okay, last one, we try to get conclusion. There are 3 conclusions. I just want to make one conclusion, that addition of Ma successfully improved physical and mechanical properties of WPC board, like as the title, but not enough yet satisfied for structural application. I think like that. Thank you very much for your attention. I return to Prof. Thank you.